Hi everyone, a very good morning to all. Now we are going to study about the question number 71, that is all about diffraction. It is similar like interference, Young's double slit experiment, but here it is all about same kind of theory but due to a single slit. There were two slits in Young's double slit experiment, and if you close one of them, then the pattern we call it as diffraction pattern. Then the phenomena is called diffraction phenomena. But first of all, we have to understand what is diffraction. Diffraction is nothing but bending of light at sharp edges. That is called bending of light. So bending of light at sharp edges, that is called diffraction. Now, when you consider or entering of light, you can also say entering of light into region of shadow. So this is called the definition of diffraction. Now, when you consider a single slit instead of double slit, now there is a slit of width A and light coming and falling on it. Then at sharp edges, the light will bend so that on the screen, you will get again the superposition principle and you will get the central bright fringe. So central bright fringe, and above and below again you will get the similar alternate dark and bright fringes, but with decreasing intensity, with decreasing width. And here the condition is for nth dark fringe, nothing but we will call it as nth secondary minima. The condition will become A sin theta equal to n lambda, where n is starting from 1, 2, 3 and so on. And n equal to 0 means, it is central one. Now, for nth secondary maxima, that means bright fringes, A sin theta equal to 2n plus 1 lambda by 2. So that distance of nth secondary yn equal to, one is n lambda d by a, another one is 2n plus 1 lambda d by 2a. This is the case of minima and this is the case with maxima. So the condition for nth maxima and minima in case of diffraction is opposite to that of interference, Young's double slit experiment. So remember these conditions so that we will solve the question based on like how the question will be asked. Or here if you observe, there is a condition like one is angular position condition, we are writing theta, and another one is linear position. But usually in Young's double slit experiment, most of the time they will ask the linear position of nth dark or bright fringe. Now, that only here we are taking what is the position of secondary maxima or minima. See here. Now from the central one. So here the central bright fringe. Now here comes the first secondary minima. Like suppose let's take this one. This is the central bright fringe. Now the immediate one is called first secondary minima. Here also now first secondary minima. Now here when you take the angular position theta, then A sin theta equal to n lambda. So n equal to 1. So A sin theta equal to lambda. So theta equal to lambda by A. So lambda by A is angular position of first minima. Now, there is one minima above and there is one minima below it, so that the total distance between them will become 2 lambda by a, angular width. This is called angular width of central bright fringe, like this. So this is also theta. So theta plus theta, 2 theta. Now, so they can ask the condition based on like the linear or angular width of central maxima, linear width of central bright fringe equal to 2 lambda d by a, and angular width means 2 lambda by a. And when you consider the diffraction pattern, see, at the center the intensity will be maximum and the intensity keep on decreases. So that the central one, if you consider I naught, then the nth secondary maxima is I naught sin beta by beta whole square, where beta is pi a sin theta by lambda, where sin theta equal to 2n plus 1 lambda by 2a. That is the condition for nth secondary maxima. So if they are asking first one n, you will substitute 1. If they are asking n equal to 2, means second secondary maxima. Depending on that, they can ask what is the intensity. But most of the times, they ask question based on the linear or angular width of central maxima, whose intensity is maximum. Now let's see few examples based on whatever formula we have taken. So here the very first thing is the width of a single slit. If the first minimum is observed at an angle 2 degrees with the light of wavelength. So wavelength they have given 6980 angstroms. And the angle is 2 degrees. Then the width of the single slit. So theta equal to what? Lambda by a. But theta we should not take in terms of degree. We have to take it in terms of radian. So pi by 180. So that they are asking to find the width a equal to lambda by theta. So then you will get the answer in terms of millimeter. Just substitute and calculate it. Then here another question. Again, diffraction at single slit. Wavelength is 5500 angstroms. First minimum is observed. That is a sin theta equal to lambda because n equal to 1. So a sin 30 equal to lambda. Then first secondary maximum is upward at an angle. So that secondary maximum means a sin theta equal to 2n plus 1 lambda by 2, where n equal to 1. So a sin theta equal to, from here a equal to 2 lambda. Now sin theta equal to 2 into 1 plus 1 by 2 into lambda equal to a is 2 lambda sin theta equal to 3 lambda by 2. So lambda cancel. So sin theta equal to 3 by 4. So this way, depending upon the given condition, you have to take the formula, whether it is secondary minima condition or secondary maxima condition, which minima or which maxima. Accordingly, you have to choose the n value. Now, if width of the slit in a single slit experiment is doubled, so linear width of central bright fringe means lambda d by a, where a is width of the slit. Now, a became double, then linear width will become 1/2. It will become what? Half. Because we are not changing the other one. So that the width will decrease means it will become sharper. Now, So here the linear width became half, so it became sharper, but the intensity increases. So the central bright fringe becomes brighter. You can take it like it is inversely proportional to square of the width. So it became double means, directly proportional to square of the width. So the intensity will become 4 times. Now the next thing is in Fraunhofer diffraction by a single slit. So again first minima, that is A sin theta equal to 1 into lambda, where lambda is given as 9000 angstroms. First order maximum is found due to an unknown wavelength, that is A sin theta equal to 2 into 1 plus 1 by 2 into lambda. Now this is lambda dash, the unknown wavelength is. Now when you take the ratio so then you will get the answer like see here. From the first equation you can get the A value, but here if you observe properly there is a small confusion is there in the question, means like the question is not 100% proper. So first they said first order minimum is formed by wavelength. So the slit width is same, but theta will be different. And first order maximum is formed due to an unknown wavelength. But in case if you consider both theta are same, then only when you take the ratio, then only you can equate both of them. Like A sin theta by A sin theta equal to lambda by 3 lambda dash by 2. So that equal to 1. So lambda dash will become 2 lambda by 3. So that you will get the 6000 answer. But here you have to understand that the both are forming at same angular position, so that theta is same for both the wavelengths. Now one last and final question. A diffraction pattern is obtained using a beam of red light. What happens if the red light is replaced by blue light? See, when you compare, on comparison, the wavelength of red light, so is greater than wavelength of blue light. Now bands become narrower and crowded together. First you consider central bright fringe width, that is lambda d by a or 2 lambda d by a. Lambda we changed, d and a remain same. As lambda decreases when we change to blue light, then central bright fringe width also what happens? Decreases. Means they become what? Narrower. When they become narrower, they come closer. So they become narrower as well as they crowded now together. So that the option B is correct. Because if you consider the distance of nth minima or maxima, it is n lambda d by a. So it is proportional to lambda. As lambda decreases, then yn value also decreases. So that the fringes will become closer. Now they come closer and they become narrower. So this is how the questions can be asked based on diffraction. But most of the time they used to prefer ask question based on Young's double slit experiment rather than diffraction. But still, just try to solve the simple kind of these kind of questions like formula based minima and maxima condition. So similar questions I have given as an assignment. So please just try to solve. And in NCERT also they have not given much questions. Just 1 or 2 questions are there. So please just try to understand. Thank you. We'll continue in the next class with the next session.